final section of Chapter 8, so we're getting into 8.6. This is another one that we're going to break up into two lessons. So you're going to get Part 1 today. On the other side of this page is Part 2, and we will do that one next time. So what you're seeing in these last two lessons, Part 1 and Part 2, are how we deal with non-right triangles. So everything that we've done this whole chapter has all been centered around right triangles. So what do we do when it's not a right triangle? So there's two formulas that we're going to learn. So Part 1, you get the law of sines, and in Part 2's lesson, you're going to get the law of cosines. So for today, we're going to look at the law of sines. And again, the main thing I want you guys to remember in both parts of this lesson is that this is the approach that we take when it's not a right triangle. When it's a right triangle, we have all those other methods. SOHCAHTOA, Pythagorean theorem, all that stuff, right? So that was for right triangles. So now we're looking at what do we do if it's not a right triangle. So the law of sines is the easier of the two. The law of sines is simply setting up a proportion, right? So the way that we would set up a proportion, and you're not going to get all three of these, you would only do two of these. So it's going to look something like this, right? So the way that we're setting up our proportion is that we're going to say the sine of an angle over its opposite side equals the sine of another angle over its opposite side. So one thing to remember in these formulas and within these drawings is they always picture a triangle like this. So just any triangle, they always name the angles with capital letters, and they always name the side lengths with lowercase letters, but it's the one across from the angle. So if this is angle A, then across from that would be side A, and they would use a lowercase letter. If this is angle B, across from that would be side B, lowercase. And if this is angle C, across from that would be lowercase c. So this is the triangle that you always want to consider when you see the formulas for the law of sines and cosines. So in order to complete one of these ratios, proportions, the issue is there's basically four pieces to a proportion, right? So I got two items on the left and I got two items on the right. Well, so we are going to know three of the four. And it's that fourth unknown piece that we're going to have to solve for. So when I look at these, I should have at least one complete ratio. So the sine of an angle and its opposite side. And then on the other side of the proportion, I should know one of the two parts of that ratio. So let me show you the one that they did, and we'll definitely be doing a couple of these on our own. But let me just show you theirs. So when I look at this, so first issue is obviously I don't have a right triangle, right? So I can't use any of the right triangle stuff that we've learned all chapter long. Okay, so that's where we turn to the law of sines, and we're going to set up a proportion that looks something like this. So I want to start with the ratio that is complete. So right here I see an angle, and I see the side across from that angle. So that is one complete ratio. So I can say sine 45 over 30. So I am completing one of those ratios. All right, and so here's the first part. Sine 45 over 30. On the other side of my proportion, I should know one of those two things. The other one is going to be my unknown that I have to figure out. So when I look at this 74 degrees, I can say the sine of 74 degrees over B. All right, this is our unknown. So when I look at this proportion, all right, you can see that I know three of the four pieces. The one piece that I don't know is this guy, and that's the one that we're going to solve for. So the way that you can solve this is the same way that we did in Chapter 7 when we were solving proportions. We cross multiply, right? So I'm going to do, sorry, I'm trying to get my arm out of the way. So I'm going to do B times sine 45 equals 30 times sine 74. So here's what that's going to look like if I cross multiply. And then if I want to get B by itself, I'm going to have to divide this over to the other side. So in my calculator, all this is going to go in to my calculator to get our side length. So that's it. So we are setting up a proportion. We're going to cross multiply, solve for our missing piece. The one little extra step that you might have to take is finding an angle by subtracting these guys from 180. So if you look at this one, obviously here is a ratio that I'm going to work with. But on this one, if this is the side that I know, I really need to work with this angle, right? The one across from it, in order to set up this ratio. So they didn't tell me that, but we could certainly figure it out, right? If I were to subtract these two guys from 180, that would tell me that my missing angle is 58 degrees. Right, and now I would have enough information to set up my proportion just like they did here. So again, on one side of this, you're going to have one complete ratio. So here's the one that we know. So we could say sine 58 over 24. So there's our complete ratio. And then we're going to match that up with the one that we're solving for. So we're going to say sine 82 over d. And so there was their setup. And again, all they did was cross multiply and solve. So let's go through 3 of these together. And that's going to be it. So this will be short and sweet. So we're going to set up a proportion here. So we're going to say, let's start with the one that we know for sure, the completed ratio. So I'm going to say sine 40 over 12. And on the other side, I'm working with these guys. We're going to say sine 80 over x. So that would be our setup. Let's do a little cross multiplying here. So on one side, I got to multiply x times sine 40. On the other side, I'm multiplying 12 times sine 80. Looks like this. And then before I go to my calculator, I like to get x by itself first. You could do this in steps, but this is the approach that I like to take. So I'm going to divide that sine 40 over to the other side. So that I can really get the full view of what all is going to go into my calculator exactly the way that I want to put that in. So again, make sure we're in degrees, not radians. One thing you have to be careful of is make sure that your calculator knows everything that's on top and everything that's on bottom, right? So if that's ever an issue, you can always put things in parentheses. So if I want to tell my calculator what's on top of the fraction bar and what's on bottom of it, I could always use parentheses. So I could say 12 sine 80 is on top, and I'm going to divide that by sine 40. So it looks like this. Now for this problem, I did not need all those parentheses. But it's a safer approach because there are times where if you don't use parentheses, you're going to get the wrong answer. So to be safe, I always encourage using parentheses. The other thing is you might have a calculator that has like a fraction mode. And so you can actually type it in like this. And it basically creates like a fraction mode for you. And so now I can simply type in what's on top and what's on bottom. Right, it's the same answer, 18.4. But we just want to be careful about the way we're putting that into our calculator. All right, let's try this one over here. We're going to practice 2 more of these. So for number 2, again, let's set up the completed ratio. Now, as you look at this one, you'll notice I don't have a completed ratio because the only side that I know is across from an angle that I don't know. So this is where we saw up above. I'm going to have to subtract those numbers from 180 in order to figure out my third angle. So I'm going to do 180 minus 52 minus 91. So 37 is our missing angle. All right, so let's set up our complete ratio. I have sine 37 is across from the 20. And I got sine 52 is across from x. So there's our setup. Let's do a little cross multiplying. So x sine 37. Sorry if you guys can hear my dog barking in the background. I'm not sure what he's barking at down there. So anyway, that's our setup after we cross multiply. I'm going to divide this over to get x by itself. So 20 sine 52 over sine 37. So there's our setup. That's how it's going into the calculator. So I'm going to do 20 sine 52 over sine 37. So it should be about 26.2. Guys, make sure you round correctly. I hate for you to miss points on a test because you said the answer was 26.1. Right? Make sure you round accurately. That 8 pushes my 1 up to a 2, so my x should equal 26.2. Alright, one more of these guys, and that'll be it for this one. So here's just a practice one. If you want to give this one a try on your own, great place to pause and give this one a shot. So we're going to be able to set up our ratios right off the bat here. So let's start with our complete ratio. So here's the side that I know, but we don't know our third angle. So again, let's subtract the two angles they gave us from 180 to figure out that missing angle. And so now we can set up that complete ratio by saying sine 62 over 16. And then on the other one right here, I got sine 84 is across from x. And that's it. We'll do a little cross multiply. So it should look like this. Now if I divide both sides by sine 62, we'll get our answer. So 16 sine 84 over sine 62, so 18.0. All right, so that's all we got for part 1 of section 8.6.